Alrighty, good afternoon or evening. Today we are going to be talking about the mole. Welcome to the best day of your life. That's a mole, the animal, not what we're necessarily going to be talking about. A mole is a mole is a mole. The mole is a specified amount of anything. It is a way of relating Avogadro's number to anything else. An Avogadro's number is equal to 6.02 times 10 to the 23rd, which is equal to 1 mole. This is something that you guys should probably write down somewhere. The Avogadro's number, 6.02 times 10 to the 23rd, is equal to 1 mole. So, a mole is a mole is a mole. 1 mole of M&Ms is then equal to 6.02 times 10 to the 23rd M&Ms. 6.02 times 10 to the 23rd books is equal to 1 mole of books. 1 mole of trucks is equal to 6.02 times 10 to the 23rd trucks. You can see where I'm going with this, guys. 1 mole of prom dates is equal to 6.02 times 10 to the 23rd prom dates. I'm telling you, it's a mole, okay? 6.02 times 10 to the 23 is equal to 1 mole. It's something that is really important for you to remember and something to keep in mind as we go forward. So let's talk about the mole in the periodic table. When you look at the periodic table and you look at an element, for example, carbon, we're given a couple different things. We're given the element's name of carbon. We're given its symbol, which is C. We're given the atomic number, which if you guys remember back to Unit 2, is the number of protons in that particular element. We're also given the average atomic mass, and this average atomic mass is the average of all the different isotopes of their number of protons and neutrons in the nucleus. Well, let's talk about the average atomic mass, because that's what's really important here. The average atomic mass of an element found on the periodic table, and keep in mind here, the average atomic mass is also known as the molecular weight. So the average atomic mass is also known as the molecular weight, and it has units of, forgot about the arrow there, average atomic mass is equal to molecular weight, and it has units of grams per mole. The average atomic mass then of carbon is 12.01 grams per mole. So that means that there are 12.01 grams of carbon for every 1 mole of carbon, or there is 1 mole of carbon for every 12.01 grams of carbon. You can see where I'm going here. It's one of what we like to call conversion factors. Grams per mole is a conversion factor, and it's given for every element. And this is really important. This is how we're going to do a lot of stuff in the future with elements. It's how we make different solutions. It's a lot, / most of chemistry is knowing the molecular weight and manipulating that. So I want you to think for a second, how many grams of chromium are there in 1 mole of chromium? I'd like you to pull out a periodic table, pause the video, Google it, whatever you need to do. I want you to figure out how many grams of chromium there are in 1 mole of chromium. And if you look on the periodic table, you should see that there's around 52.0 grams of chromium in every 1 mole of chromium. So then what is the average atomic mass of silicon? Okay, I'd like you to pause and take a look at this. And if you look it up on the periodic table, you see that it is 28.09 grams per mole. So, now for the map that will take you anywhere, the mole map. And this is definitely something that you are going to want to write down, because this is how we're going to be utilizing these conversion factors, how we're going to be utilizing the mole from now on, how we can convert it and relate it to anything. Our mole conversion pretty much, when I say it's the map that'll take you anywhere, I mean it. You can get pretty much anywhere knowing moles. It's like a universal conversion factor. So, let's look at this. So we start out with moles. If we want to go from moles to mass of an object, all we need to use is the formula weight, or the atomic mass, or the molecular weight, whatever you want to call it, of grams per mole. There's our conversion factor from moles to mass, grams per mole. If we want to go to particles, say the number of atoms or molecules or what have you, we're going to use Avogadro's number. 1 mole for every 6.02 times 10 to the 23 particles, or 6.02 times 10 to the 23 particles per 1 mole. So that's what we were doing in the beginning when we said that for every 1 mole of books, there are 6.02 times 10 to the 23 books. So this is that idea there. We can also relate moles to the volume of an ideal gas at STP, and STP here is standard temperature and pressure. And so the volume of an ideal gas at STP can be related to moles through the use of 22.4 liters per mole, okay? So there are 22.4 liters of an ideal gas at standard temperature and pressure for every 1 mole of gas. So pause the video, write this down, record it somewhere, whatever you want to do, and then we're going to go on. So let's apply this. What is the mass of 1.40 moles of carbon? So the way that we're going to do this is I start out with what I know, 1.40 moles of carbon, and then I multiply that by the formula weight. We're doing mass to moles, we're going to multiply it by grams per mole. So here, the formula weight or atomic mass or molecular weight of carbon is 12.01 grams of carbon for every 1 mole of carbon. So our moles of carbon are going to cancel out, leaving us with grams of carbon. And if you multiply 1.40 by 12.01, you get 16.8 grams of carbon. That means that in 1.4 moles of carbon, I have 16.8 grams of carbon. So what if I wanted to go the other way? How many moles of carbon are in 5.84 grams of carbon? So as always, start out with what you know. You know 5.84 grams of carbon. You also know the formula weight, or average atomic mass, or molecular weight of carbon, as 12.01 grams of carbon in every 1 mole. This time, however, the moles are on top, and that's because that is the unit that we want to solve for. And also, we need to cancel grams, so grams need to be on the bottom. This is the whole unit conversions coming back. It's that shadow that I told you was going to follow us around for the rest of chemistry. It's coming back, guys. So my grams cancel out with my grams canceling out, leaving me with moles of carbon. And if I divide 5.84 grams by 12.01 grams, I get 0.486 moles of carbon. Okay? I want you to try this now. So I'm going to give you a problem, and I'd like you to pause the video and actually work it out. So how many atoms of nitrogen are in 1.24 moles of nitrogen? So you may need to use a different conversion factor here. Go back to your mole map, figure it out, figure out what your conversion factor is, how you're going to relate moles to atoms, and do that for yourself, and then check back with me. So we should have started out with what we knew. Sorry, I did a typo there. I said 1.45 moles of nitrogen. That's probably what I did my calculation with, so just bear with me there. So 1.45 moles of nitrogen times 6.02 times 10 to the 23 atoms of nitrogen for every 1 mole of nitrogen. Our moles cancel out, leaving us with atoms of nitrogen, and an answer of 8.73 times 10 to the 23 atoms of nitrogen. I'm sorry, I can't remember if that's for 1.45 moles or 1.24 moles, but if your work is the same as my work, even if your answer is different, it's probably the right answer. What about how many moles of carbon dioxide are in 45.2 liters of carbon dioxide at STP? So look at your mole map and figure out how you're going to do this. So you should have started out with what we knew, which is 45.2 liters, and multiplied it by our conversion factor, which this time is 1 mole for every 22.4 liters. Liters is on the bottom because we're trying to solve for moles. Remember, these fractions or these conversion factors can be swapped whichever way you need to get the answer that you're looking for. Whichever unit you need to solve for, that's the unit that should be on top. So our liters are going to cancel out, leaving us with moles. 2.02 moles of CO2 gas. Alright, I hope that you enjoyed learning about the mole. We're going to spend a few days on this. This is, like I said, an essential part of chemistry, and it's really important that we get it down. So we're going to be spending a lot of time practicing this, so I hope you understand it, and I look forward to talking to you guys about it tomorrow. Have a good night. Bye.